Assalamualaikum, my name is HANIF ASRI and my number 3 is AA200784. So I'm going to tell you about the introduction of our project. So because the increase of urban population and media section is contribute to the increasing number of vehicle. By the increasing of number of vehicle, then it is hard for emergency vehicle to get to the nation early as possible. So this project is to overcome or reduce the time travel of the emergency vehicle. So the name of our project is called the E-Bus Simulation Smart Sensing for Emergency Vehicle, and the objective of this device is to reduce the travel time. So the design of this E-Bus will be placed at the pole middle section of the traffic light. So the device will detect the approaching of emergency by detecting the siren of emergency vehicle. Then it will change the red light to green light. So the objective is to design the device that efficiently detect the siren. Second is to design a device that is easy to understand for road user. And finally, to develop a complete design of smart sensing for emergency vehicle using a software. So the project scope of our project is we want to decide the design that called E-Bus Simulation of Smart Sensing for Emergency Vehicle, as I told at the introduction. And the aim of the device to reduce the time travel of emergency vehicle to reach the destination effectively, because they need to reach the destination as soon as possible. So the E-Bus reduces time travel for emergency vehicle by changing the red light to green light, like I said in the introduction statement. So the prototype is made by modeling using SolidWorks. So for the project significant, the type of microphone sensor will be used for the E-Bus is to provide to be reliable as it detect the sound from the distance from the traffic light. E-Bus introduced the real-time testing case study and is exposed to the limited time during peak and non-rush hour. The case study allowed to evaluate the efficiency of providing a faster emergency response to minimize the delay on the traffic. To ensure our reach is very relevant, we will propose this project to Jabatan Kerja Raya JKR and also Jabatan Pengangkutan Jalan Raya JPJ. Now we go to the chapter 2, which the subtopic is the product design specification. Product design specification divided to 6 parts. So we go for the first is the appearance. The product of E-Bus is for the outdoor use. The height is good for tall vehicle and product size isn't excessively large and appropriate for seating in which it will be used. The product will be installed at the mid section of the traffic light pole. Next we go to the material. The material that we use for this project is easy to find at a shop and also easy to handle. The advantages of this material is non-corrosion and long-lasting. It is because the material will be long-lasting with changes of weather as it will put outside. Then we go to the product cost. Every product has its cost. So for this product is just affordable. Not only that, the manufacturing cost of this project is also reasonable. The material that to be purchased is separately so that it's easier to calculate the cost. Next we go to weight restriction. The weight of E-Bus is suitable with the strength of the traffic light pole. The product is not heavy because we use light material. Next we go to the product lifespan. The material has different lifespan as the material utilized the life duration may be extended for many years. Because the material are readily available, they can endure longer with a proper maintenance. We go for the last is maintenance. The material used may last longer depending on the product. the maintenance will not drastically alter. Not only that, the material is corrosion resistant and also long lasting. It's possible to reduce the time required for maintenance by utilizing the appropriate material. Now we go to the product function. The e-bus will help to reduce the time travel for emergency vehicle. The siren of emergency vehicle will be detected by microphone sensor. Then the sensor will transfer the frequency of emergency vehicle to the system, and the system will change the red light to a green light, and then the emergency vehicle easily get through it. Now we go to the design requirement and criteria. First, we go to the requirement. It made out of material that is suitable to last and long lasting and non-corrosion. Second is product cost above RM 400. Third is the product can last for 50 years. And finally, easy to maintain because the spare part can be found easily at shop. Next, we go to design criteria. It can be used safely because there is a lot of support at the traffic light pole. Second, the distance of the e-bus to detect the siren. Next is the road user friendly, and finally consider the effectiveness of the sensor to detect the sirens.
Assalamualaikum warahmatullahi wabarakatuh, and hi, my name is Muhammad AKMAL bin Abdul Halim, matrix number AA200-308. Today I'll be explaining regarding the chapter 3 background research of our engineering design project titled e-bus simulation of smart sensing for emergency vehicles. Alright, first and foremost, Malaysia has the fourth worst traffic congestion condition in Asian country. The increase in the urban population and middle class contributed to the increasing of vehicles, traffic congestions and delays. Therefore, it will lead to slow traffic, increasing travel time, and this become a major problem. So, it is imperative to improve the travel time and efficiency of transportation, especially when it comes to emergency vehicles. Emergency vehicles are permitted by law to violate the usual rules of the road in order to get to any particular location as quickly as possible. The delay of emergency vehicle due to traffic can cause the likelihood of victims' death. Preemption, or maybe known as a time division, can be an aid for emergency vehicle to reach the intended destination in a significantly shorter amount of time. Thus, there is a need towards the application of smart sensing for emergency vehicles. This project goal is focused on the simulation of smart sensing for emergency vehicles using software. Thus, I would say the aim of the e-bus simulation of smart sensing for emergency vehicle is simply to ease the authorities that are responsible to react towards this emergency, such as the ambulance, police, firefighters, and many others. Now, as seen, this is the flowchart of the e-bus. So the design of the e-bus consists of 5 phases, which are the research phases, conceptual design, followed by the detailed design, the design output, and finally the conceptual design of the digital fabrication, or rather known as 3D printing. So from the figure, so these 5 phases in designing modern products, every phase has its own subtopic to be discussed on. So every phase is a vital step in product improvement, as it will assist to visualize the step in designing and could assist us to perform this assignment with terrific result. Now, the early level of this research phase method consists of layout and studies, knowing what we have, what we want, and in which to get, in addition to the ways of to get the required facts from the micro knowledge to apprehend the significance, the usage of present information as a beginning factor. So the usage of analysis and synthesis method and so on. So to combine the vital influencing method of the goods worded, so that we can manually follow out layout in focused manner. Thus, this is the research phase. For the conceptual design stages, based on Cheng, which from our reference, assessing conceptual design stages is assessing a person's previous market needs and desires. This is what called conceptual design or conceptual layout stages. So this takes form of an ever-changing system after the above layout position is determined. From rough to fine, for example, fuzzy to sharp, short to create layouts using specific procedures. As for the detailed design, it is an operating draft system of rendering and in an advanced layout concept. It's steadily paperwork, a visually clean plan, increasing and branching in step with the layout concept. When compared the assignment and carry out software choice and optimization, it's not of the most effective the product representation. However, the system is carried out in that detailed design. For the design output, it's the degree of interference of layout is most often associated with expressing the effect of a layout, initial instructions for the next production. So for the conceptual design of digital fabrication, to put it short, it is 3D printing, or you could say rapid modeling of the design. Some designs from previous studies became our sample designs that others had done throughout the early design phase, and some fresh concepts were developed. So this design also uses the concept of traffic light that has a single signal light besides a sensor to inform the road user. So the aim of the design is to have a big dimension to provide a suitable space for other electrical components and make it easy for emergency vehicle drivers to recognize this signal light. The design of this device is approximately not bigger than traffic light to avoid confusion to other road users. So this design also takes the effectiveness of the sensor working principle to increase the volume of emergency vehicle siren by implementing the audio amplifier to run on this system. So to have the effectiveness of the sensor, the best place or suitable place to put the sensor of device is outside of the device. So based on what I have explained, several design and characteristics that are suited for a project were chosen. So what are the characteristics? Above, the table above shows the characteristic of the e-bus can be divided into 5, which is function, ability, size, cost, and material suitability. So as for the function, is to detect the emergency vehicle siren. The ability, to change the red light to green light with the sound of emergency vehicle. The size is significantly smaller than traffic light. It is high cost, and for the material suitability, we used galvanized steel to provide the requisite corrosion resistance and strength. Polycarbonate for corrosion resistance. Now I'll be explaining regarding the chapter 4, which is the conceptual design. The design concept generation is a part where the idea generation occurs. So in this stage, we have to look at the problem from various aspects, and this will result in a concept that we may have not even come up with without some deep thinking. This is a crucial part of the product development process. Besides, we also get to discuss with each other from our teammates to find out the suitable design and material. So from our discussion, we are able to identify several aspects. The aspects are: first, material; second, appearance; third is the weight; fourth is the product lifespan; fifth is the maintenance; sixth is the realisticness of the application. So based on the aspect which we have considered, this is the conceptual design of the e-bus. As you can see, it's huge. It fulfills all the characteristics which we have mentioned. This is the exploded view of the e-bus. In order to achieve all the requirements, the components of e-bus which have been produced, and each part has serve different purposes. So each part has been determined by the function to create the prototype of the e-bus. So the table shows the all the components of the e-bus and their functionality. So first is the siren base. Siren base function as the base for siren for emergency component. It has one quantity. The siren cover is to protect the rotating part inside this cover. It has one quantity. For the rotating part, it is to give the road user a notification or signal of an emergency. It has one quantity as well. As for the bracket, it is to connect and support the microphone sensor and the siren of the emergency part. it has one quantity as well. As for the microphone sensor, which is the main, is to give a sign to a siren when it is to detect, basically to detect, to trigger from the siren, and gives to trigger basically the whole device. Then we have bolt of 20mm to connect other component to connect with another component. We have 4 bolt of 20 size of 20mm, and we have bolt size 10mm 6. This is to connect component with another part. Then we have mount, which is to complete the bracket with the mount hook. Yes, also one. We can conclude that the conceptual design plays an important role in order to really brainstorm the design concept of the e-bus. The idea generation occurs in this stage. We have to take a look at the problem from various aspects and propose a relevant design concept that is realistic and at the same time serves its purposes. The e-bus device consists of 13 components in this chapter. All of the components, the quantity and the function, they have all been explained in detail in this chapter. A design concept of evaluation is also performed by box chart analysis, which can be seen in the report. This is to validate the design based on several aspects which have been identified. For the chapter 5, which is the embodiment design. Now, this is the dimensional modeling of the e-bus. So this design consists of 13 components, which are the siren base, siren cover, rotating part, bracket, microphone sensor, bolt of 20mm and 10mm, and the mount. So this is the whole dimension of the e-bus. You can see it's been detailed for each and every component and part, the sizing and the dimension. Alright, now for the calculation part, we use the first we have to calculate the centroid. So we use the formula that we plug in. So we use pi r square times 100 divided by pi r square. So pi, the radius is 100, pi times 100 square times under 100 divided by pi times 100 square. Then we'll get 100 for our centroid. Once we find our centroid, we have to calculate the moment of inertia. For the circle, we use the formula pi over 4 times 100 to the power of 4 plus pi over 4 times 200 squared times 100 squared. Then we plug in using a calculator, we'll get 392.7 times 10 to the power of 6 millimeter power 4. Then we find the stress of compress by implementing the formula which is shown. We plug in 50 times 0.1 divided by the moment of inertia of circle, which is 392.7 times 10 to the power of 6. Then we'll get 1.27 times 10 to the power of 8 megapascal. Then we find the stress for tensile. Using the same formula, we plug in 50 times 0.1 divided by 392.7 times 10 to the power of 6. Then we get 1.27 times 10 to the power of negative 8 megapascal. Then finally, we plug in 1.27 times 10 to the power of negative 8 divided by the modulus elasticity of alloy. Then we will get 6.68 times 10 to the power of negative 11. Alright, that's all for me. Thank you. Now, as for the material of the e-bus, all the selection of materials will be utilized and have certain tasks and functions that are required to make the good product, so that the product can function well. So to make the device operate well, we have to make sure the right choice and addition of the material to ensure the work of the project and the objective of the project can be fulfilled. So after discussion and researching, we have determined the suitable material that qualifies to be used to our product in order for the product to operate properly. So here we will be explaining on the table the suitable material and justification of material for each component. So first, for siren base, we have choose plastic. Why? Because it is tough, it is resistant towards rusting, and UV stabilized to provide years of safety. For siren cover, we have used plastic as well. It is for the same reason, because it is tough, resistant toward rusting, and UV stabilized to provide years of safety. As for the rotating part, for the material we use high strength low alloy steel. Why? Because by using high strength low alloy steel to maintain formability and weldability. over energy low alloy metals have excessive slip and corrosion resistance, but flaw properties along with corrosion resistance and micro hardness can similarly be improved by manipulating the melt to form a premium dense grain layer on the floor. Next, for bracket, we use stainless steel because it is highly durable due to its corrosion resistant and it's durable. For bolt, 20mm bolt, we use stainless steel because of its high durability and corrosion resistant. Same for the 10mm bolt, we use stainless steel due to its high durability and corrosion resistant. As for the mount, we use alloy steel because by using alloy steel, it has high tensile strength and easy compressibility. As for the mount hook, we use alloy steel as well due to high tensile strength and easy compressibility. As for the nut size M14, we use stainless steel because it is high durability and corrosion resistant. For the bolt, we use alloy steel as it has high tensile strength and easy to compress. For the display screen, we use LCD for the in-long liquid crystal display. So why we use LCD? Because by implementing LCD for our display screen, high energy efficiency and low power consumption, so easy and save energy at the same time. For the display screen mount, we use alloy steel because it has high tensile strength and easy compressibility. Next, for the sensor justification, the pros and cons of each sensor are studied in depth. Upon the study of microphone sensor is chosen due to its capability to ignore various waves and frequencies and has a high detection level for the sound of emergency vehicle. So what are the other options that we have instead of microphone sensor, and why do we choose the microphone sensor? So below in the table, we'll be analyzing a few sensors and the justification on why we neglect certain sensors and we choose the microphone sensor. So first, for the ultrasonic sensor, it emits ultrasonic sound waves above human hearing. So why do we neglect or did not use this sensor? Because it has low detection and low detection, especially in water penetration level rain. So as for the color sensor, it detects unnecessary colors. So why we neglect this sensor? Because we want to avoid confusion to the traffic light colors. As we know, traffic light has 3 different colors. So if you implement the color sensor, the sensor might be confused to detect colors. Secondly, color sensor is unable to detect sound. As we know, ambulance uses sound as well as color. So if you implement color sensor, it will neglect sound. Now for the light sensor, it depends on the intensiveness of the light. So it uses the usage of automatic switches. So as for the justification, to detect the amount of light and raise or lower the blinds or switch on of the lights automatically. Now for the microphone sensor, it ignores various waves and frequencies, and simply put, why do we choose the sensor? Because it has a high detection level for sound. Now here is the approach of the E-bus functioning. As you can see, it starts, then emergency vehicles approach, then we have siren and without siren. So if siren, E-bus detect the siren, signboard appear, please move, and red light turns to green, then back to normal. If without siren, E-bus does not detect the siren, nothing will appear on the display screen. The traffic light color does not change, and back to normal system. To put it short, the way of the E-bus function is divided into 2 ways. First, when the E-bus detects the approaching of the emergency vehicle with siren on, then without siren. So which I have just explained. The process is simple. So all of the elements which I have mentioned are the critical differentiators between our goods and those presently on the market. Consider the product's likelihood of failure as well as the maximum performance that may be attained. We have worked really hard to ensure this product design and production were error free. So no worries.
Now we go to the chapter 6, and the subtopic that will be discussed is finalized design. So based on the diagram, you can see this is the design that we have finalized. So what we have for the design is pull nut M40, mount hook, mount bolt 10 mm, display screen mount bolt 20 mm, siren base, siren cover, rotating part, bracket, microphone sensor and display screen. Then for detailed drawing, we will talk the material that made from stainless steel such as nut M40, bracket, bolt 20 mm, bolt 10 mm. This is because it is highly durable to the its corrosion resistant and durability. Then we talk about this alloy steel that made for the part such as display screen mount, pull, mount hook and also mount. D is because the alloy steel has high tensile strength and easy compressibility. Then we go to the siren cover, siren base that made from plastic. The reason is we choose is because plastic has tough resistance toward rusting and UV stabilized to provide year of safety. So for display screen, the material that we choose is liquid crystal display that's known as LCD. It is because it has high energy efficiency and low power consumption. And then for the rotating part, the material that we choose is high strength alloy steel. This is because it can maintain formability and weldability. Over energy low, alloy metal have acid, slip and corrosion resistant, but flow properties along with the corrosion resistant and micro hardness can similarly be improved by manipulating the melt to the form a premium dense ground layer on the floor.
Assalamualaikum, my name is Muhammad ARIF RANI. My matrix number is AA200-324. So today, I will continue for our presentation group. So I will discuss about the chapter 7, which is a conclusion of the project. Okay, we go for the next slide. Okay, for the conclusion, this project is titled E-Bus Simulation of Smart Sensing for Emergency Vehicle. The device comes with a variety of advantage. The main purpose why the device should be developed is to help the user of a siren vehicle to move effectlessly in the traffic without facing a jam. It also definitely can reduce the travel time of the siren vehicle such as police or ambulance. By applying the device, it can send the patient to the hospital nearby as fast as possible. Basically, the device this product come with three main components, which is the siren, microphone sensor, and display board. All these components play the main role in order to operate this device efficiently. In Malaysia, there might be some light sensor that have been used by JKR, such as a wireless vehicle detector (WVD) sensors. Besides, in this project, we apply the traffic light sensor with a microphone technology to make sure that our project is not the same as the previous research. However, this device is not only to focus more to ambulance vehicle, but also other user siren vehicle such as police, firemen, and a jet pump. During the making of design product, there are many challenges that must be faced, such as how the device operates and how to relate this project with the mechanical field. However, this problem can be resolved by solving a lot of paper and the previous research in order to create a solution to solve the existing and upcoming issue. Sometimes the issue are in the conclusion of the chapter. It is because it needs to understand the overall content of the chapter before summarizing the chapter. The problem also comes when we have to discuss and understanding each other's ideas. since it was our first time to produce a new product. But then, we finally are able to brainstorming all the idea of the group members and manage to solve it together. It is necessary for a team member to make a reasonable commitments and demonstrate their ability and skill in order to produce the greatest result. Moving on to the next slide. 7.2 recommendation. Okay, in this recommendation, in the future, we plan to improve the eBus device to make it more better. The enhancement that can be made by apply other electronic component like amplifier. It is because this component can increase the power of signal, which is in this case we want to enlarge the sound or decibel from the silent vehicle. It also can improve the effectiveness of sensor in order to receive the signal from a silent vehicle with greater distance than before. This improvement will surely make this eBus device more usefulness than other sensor because only microphone technology that can apply this amplifier. Next, we can add more components or parts in order to make eBus operate in a range situations. Instead of adding more parts, we can also apply a new technology or mechanical part to make sure the microphone sensor are able to run in those situations and also to prevent the device from being exposed to the rain that come from rain, from being exposed to the water that come from rain. So the device will not damaged by water if this new technology is applied. Besides that, we can replace a better material for eBus device that more anti-corrosion and heat resistance. It is because all selected material, as we discussed before, can be improved from day to day. Lastly, we will improve the design of eBus device by applying the dynamic concept in order to reduce the wind resistance as this device is located at high position. As the result, eBus device will be more stable at this position. So that's all that recommendation that we suggest. So that's all for our group. I hope you can understand and thank you.